Chapter 6, Arrays and Array Lists, Part 3. So the enhanced for loop allows us to walk from the beginning of an array to the end, visiting each element one at a time. I prefer to use the term traverse. The author of your textbook uses the term walk in that it implies visiting the first one and each one all the way to the end. But traverse, I find, is more commonly used in programming. The enhanced for loop is pretty handy in that it takes care of all of that subscript and increment for us and testing automatically. So the way that we set this up, know that when you use the enhanced for loop, you can't traverse part of an array. It's always going to go through the whole thing from beginning to end. So the way we set this up is we start with a keyword for, and then in parentheses we put the data type of the elements in our array. In this case, in the case of the example in the gray box there, the data type is double. And then we use a temporary name. So whatever element we're currently on, what are we going to call that element while we're visiting it? And it's common to use element or E as a name implying the current element. Some people use current. It really doesn't matter as long as it's a valid variable name. And then we use a colon followed by the name of the array. So for double element colon values. So each time through the loop, element is going to contain the current element in the array. And in this example, in the gray box, we are summing all of the elements in the array. A couple of things to be careful of with the for each loop. Number one, as I mentioned, you start at the beginning and go all the way through to the end. You can't access part of the array. And number two, you can't change elements while you're visiting them. So it essentially is setting up a read-only access to your array. You can't modify the elements. You can just access them and read them. It is not possible to get a bounds error when using an enhanced for loop, and that's kind of nice because bounds errors will cause our program to crash. Here's the syntax again. We start with a keyword for, followed by the data type of the elements in the array, followed by a variable name, a colon, and then the name of the array. Notice in this syntax example here it says collection instead of array name. An array is what we're currently working with, but there are other types of data structures for which you could use the enhanced for loop. So let's talk about some common array algorithms. It's common to need to fill an array with elements, to sum and average values in an array, to find the smallest and the largest values in an array, to output the elements with some separators or special formatting. It's common to want to do a linear search, that is, search for an element in the array starting at the beginning and going all the way to the end. You might want to remove an element or insert an element or swap a couple of elements. You might want to copy an array, and you might want to read input and put that input into an array. So let's take a look at some of these. Filling an array. So to fill an array, notice that we are not using the enhanced for loop, we're using the traditional for loop, and we create our array int square brackets values equals new int 11, so there are 11 elements in this array. For int I equals 0, I less than values.length, I plus plus, that's very common for traversing an array. Start with 0, go as long as the loop control variable, in this case I, is less than the number of elements in the array, values.length. And we are setting each element, in this example we're setting each element to the square of the subscript. It doesn't have to be thus. It depends on what your purposes are, what you initialize each element to. But in this case, they are just showing as an example, initializing each element to the square of the subscript. We can sum and average array elements. Notice in this case that we are using the enhanced for loop because we don't want to modify the elements in the array. We just want to access them. We just want to read them. And in this case, we are totaling all the elements up by saying total equals total plus element. And then when we're done with that enhanced for loop, we divide our total by the number of elements in the array to come up with the average. Notice there's an if statement, if values.length is greater than 0. Now why would we ask that? Well, if values.length is greater than 0, there are actually values in that array. Secondly, if it's not greater than 0, we would get a divide by 0 error. and that would cause our program to crash. Finding the maximum and the minimum. The first thing that we do, the most important thing, is we set the largest, if finding the maximum, we set the variable where we're going to store the largest, we set that equal to the first element. And the reason that we do this is because if we haven't looked at any elements so far, the first one is the largest one. So we set the largest equal to the first element in the array, and then we use a for loop to traverse the remaining elements. So for int I equals 1, I less than values.length, I++. If value sub I, that means the current element, is greater than the one I think is the largest, the one I've stored in that variable largest. If the current one is greater than the largest, then set the largest equal to the current one. By the time I'm done with the for loop, the variable largest will contain the largest value inside the array. Similarly, to find the minimum, we use a variable smallest, we set it equal to the first element in the array, and then our if statement is if the current element is less than the smallest, then we set smallest equal to the current element. Let's look at those two gray boxes at the bottom of the slides for a moment. They're both using an enhanced for loop. So double largest equals values sub 0. And then for double element, colon, values. So we're using the enhanced for loop to access each element in the array. If element greater than largest, notice the typo. There's a missing open parenthesis on this slide. So if open parenthesis, element greater than largest, close parenthesis, largest equals element. Similarly, with the algorithm for the smallest, it is also missing that open parenthesis. Element separators. Sometimes we want to print some formatting between our numbers, such as a comma or maybe a vertical bar. And to do this, we want to output all the elements with separators between them. We don't want to have a separator before or the first element or after the last element. So we've set up a for loop to access all the elements in the array. And we have an if statement. If I is greater than 0, that means if we've already printed out the first element, then we print our separator, followed by printing the value sub I. And you can see that if we keep doing this, we will get separators between all the elements, but not before the first one or after the last one. A handy array method, you can use arrays.toString, and that method will print out all of the elements in the array. So if we say system.out.println arrays.toString and then in parentheses we put the name of our array, in this case values, it will print out all of the values in the array. This is kind of handy because you can double check that the array actually contains the values that you think it does. So a linear search is when we start at the beginning element, the first element in the array, and we're looking for something. We visit each element until we find it. So in this case, we want to search for the value 100. We set int pose equal to 0. Pose or position will contain the location of the value once we found it. Boolean found equals false. So this is our flag that we're going to use. If we find it, we'll set that equal to true. Well, pose is less than values.length, so this position is less than values.length. We haven't searched all the elements yet, and not found, so we haven't found what we're looking for. Remember, the AND logic operator requires that both of those conditions to be true in order for the compound condition to be true. So we still have elements left to search, and we haven't found what we're looking for. If value sub pose equals searched value, then we set found equal to true. Else, we set position plus plus. Then, there is a missing close brace in this code segment. Notice after the else, there's an open brace, so there should be a close brace to match up with that open brace. Also, there should be a close brace. That close brace, there should be another close brace right there. So, I'm sorry, this is confusing. Else, open brace, pose plus plus, semicolon, close brace, close brace. We need to close that while loop before we access the if statement. Why? Because we don't want to say that it's not found or that it's found every time through the loop. We only want to say that when we're done looping. So then we have if found and system.out.println found at position pose. Else system.out.println not found. Here is an example of an algorithm where we are removing an element. It's important to remember that arrays in Java are immutable. That means we can't change the size of the array when the program is running. However, we can use only a portion of the array. So if we are using just a portion of the array, we can remove a current element, we can remove an element and then update our current size. We don't want to leave a hole in the array because it's important for us to be able to process all the values in the array, all the values that we're using. So holes can mess up our data. So here's what we do. We need to remove an element and then we need to scooch all the other elements into that up because we've removed an element in the middle, and then we need to change current size, subtract 1. So if for int I equals pose, so the position of the element we want to remove, I less than current size minus 1, because we're just going to move all the elements up from the subsequent element up to the current location. I plus plus. Value sub I equals value sub I plus 1. So the current location is going to be equal to the next location in the array. And we do that all the way through until we get to current size minus 1. And then we set current size minus minus. So that subtracts 1 from the current size. So now it's updated. We've subtracted an element from the list.